Hi guys, here's your video on 4.1 radian and degrees. So after you're done watching the video, you should be able to use radian measure, degree measure, and use angles to model and solve real-life problems. So the first couple of slides is just looking at a few definitions. So when we're drawing angles, you have an angle that's in standard position where the initial side is on the positive x-axis. So right here is your positive x-axis. So that's your starting position for your angle. And depending on how you move, that's going to determine if you have positive angles or negative angles. So a positive angle is where the terminal side rotates counterclockwise. So for example, if my terminal side is over here, and I actually went counterclockwise to get to that terminal side, that is a positive angle. For negative angles, I'm going to use the same terminal side, but that's where the terminal side rotates clockwise. So instead of going counterclockwise, I'm starting on my positive x-axis and I'm going clockwise. And this is a negative angle, and then going counterclockwise is a positive angle. If you'll notice, both of the angles that I drew have the same terminal side. So positive and negative angles just differ by the direction that you were moving. The fact that the two angles that I drew have the same terminal sides makes them coterminal angles. So that's the next definition. Have the same initial and terminal sides. And when you're finding coterminal angles, what you can do is you can add or subtract a full rotation or revolution, and then that'll be multiples of 360 for degrees and multiples of 2 pi once we start talking about radians. Now, one of the things that your homework is going to ask you is where that particular angle is in the quadrants. So when we're looking at degrees, your positive x-axis is 0 degrees. And then each quadrant is 90 degrees, so then your positive y-axis is 90 degrees. Negative x-axis is 180 degrees. Negative y-axis is 270 degrees. And then if I go back to my positive x-axis, that's 360 degrees. So any of these angles from 0 to 90 would be in the first quadrant, 90 to 180 would be in the second quadrant, 180 to 270, third quadrant, and 270 to 360 in that fourth quadrant. Some important terms that you might encounter, the vertex is where your terminal side and your initial side meet. So I'm going to draw it in purple over here. This right here is your vertex. Same thing for that positive angle. Whoops. A right angle is 90 degrees. And acute angle is an angle that's less than 90 degrees. Obtuse angles are greater than 90 degrees. Complementary angles add up to 90 degrees. Supplementary angles add to 180 degrees. And the central angle we'll talk more about once we do arc length and area. Okay, the next definition we're looking at is something called a radian. So a radian is just another way to measure an angle. Just like you can measure in inches and centimeters, you can measure an angle in degrees and radians. So the radian is a measure of a central angle of a circle subtended by an arc equal in length to the radius of a circle. Now that definition is a little confusing, but just remember that a radian is just another way to measure out an angle. Two important things with radians. 360 degrees is equivalent to 2 pi radians, which means 180 degrees is equivalent to pi radians. So when I label my quadrants, my positive x-axis is 0 radians. My negative x-axis is pi radians. And if I go back another 180 degrees, my positive x-axis is 2 pi radians. Now for the 90 degrees, since it's halfway between 0 and pi, it's half a pi. So that's pi over 2. And then halfway between pi and 2 pi is 1.5 pi, or 3 pi over 2. So again, your homework is going to ask you which quadrant the radian measure falls into. So you have 0, 90 is pi over 2, 180 is pi, 270 is 3 pi over 2, and 360 is equivalent to 2 pi. You're also going to have to convert between radians and degrees, and to do that you're either going to multiply by 180 over pi, or you're going to multiply by pi over 180. It just depends on what you start with. Okay, so let's go back and talk about coterminal angles. So coterminal angles share an initial side and a terminal side. So to find coterminal angles, you're adding or subtracting a full rotation. So for letter A, my angle measurement is degrees, and a full rotation in degrees is 360. So I'm going to add or subtract a full rotation, 360 degrees, to find a positive and a negative coterminal angle. So the first one I'm going to do is a positive coterminal angle. So I'm going to take 45 degrees plus 360 degrees, and that gives me 405 degrees. So I have a positive coterminal angle of 405 degrees. For a negative coterminal angle, I'm going to start with 45 degrees again and subtract 360, because again I'm taking away a full rotation. So 45 minus 360 is negative 315 degrees. Now there's actually an infinite amount of answers that you can have for coterminal angles. So for example, if I wanted to add another 360 to 405, that gives me 765 degrees. 765 degrees is another coterminal angle for 45 degrees. And same thing for the negative coterminal angles. You can keep adding, you can keep subtracting 360 and you'll get other coterminal negative angles. For radians, a full rotation is 2 pi. So instead of adding and subtracting 360, I'm adding and subtracting 2 pi. So for my positive coterminal angle, I'm going to start with negative pi over 3, and I'm going to add 2 pi to it. Well, 2 pi, in terms of 3's for my denominator, is 6 pi over 3. Alright, just getting that common denominator because 2 pi is the same thing as 2 pi over 1, so I have to multiply my 2 pi by 3 over 3 to get that common denominator. So that gives me 5 pi over 3. So a positive coterminal angle for negative pi over 3 is 5 pi over 3. For a negative coterminal angle, I'm going to start with negative pi over 3, but now I'm going to subtract 2 pi. And again, I need a common denominator since I'm adding and subtracting fractions. 2 pi is 6 pi over 3. Right, because 6 divided by 3 is 2, and then that gives me negative 7 pi over 3. So my negative coterminal angle for negative pi over 3 is negative 7 pi over 3. Now if the fractions for letter B is something that you struggle with, you can always use the calculator. So for example, for this positive coterminal angle, in the calculator I can just take 1/3 plus 2, change it back to a fraction. That'll give you the 5 over 3. Just reattach the pi to the numerator. And then for the negative one, I can take negative 1/3 minus 2, change it back to a fraction, hit math frac, and then that'll give you negative 7 over 3. Just reattach that pi to the numerator. Complementary and supplementary angles. So complementary angles, once again, those add to 90 degrees. And supplementary angles add to 180 degrees. If we're talking about radians, they add to pi over 2 because pi over 2 is equivalent to 90 degrees. And supplementary angles add up to pi, since 180 is equivalent to pi radians. So for letter A, find an angle complementary to 73 degrees. So the complementary angle, I'm going to take 90 minus 73 degrees. 90 minus 73 is 17 degrees. So the complement of 73 degrees is 17 degrees. And then the angle supplementary to 103.28, I'm going to take 180 minus 103.28 degrees. So 180 minus 103.28 is 76.72 degrees. So the supplement to 103.28 is 76.72. For radians, they have to add up to pi over 2. So for pi over 5, I'm going to take pi over 2 minus pi over 5. So if I wanted to, in the calculator, I can take 1/2 minus 1/5, and then just reattach the pi to the numerator. So 1/2 minus 1/5 is 3/10. So that's 3 pi over 10. So the complement to pi over 5 is 3 pi over 10. The supplement to 3 pi over 4, I'm going to take 180 degrees, which is equivalent to pi, minus 3 pi over 4. Again, if you want to use a calculator, go for it. It's 1 minus 3/4, which is 1/4. So just 1 pi over 4. So again, just to reiterate, complementary angles add up to 90 degrees or pi over 2 radians, and supplementary angles add up to 180 degrees or pi radians. The next thing we're looking at is converting back and forth from radians to degrees. So there's two ways that you can do that. You're either going to multiply by pi over 180, or you're going to multiply by 180 over pi. And it really depends on what you start with. So if I'm starting with 300 degrees, and I'm trying to convert that to radians, I need to be able to cancel out that degree, which means my degrees needs to be on the bottom. So 180 degrees needs to be on the bottom, and then pi on top. And then you can multiply straight across. Your degrees cancel. So that gives me 300 pi over 180. And then 300 over 180 you can reduce. Use a calculator if you want to, which is exactly what I'm doing right now. That reduces to 5 pi over 3. When you are working with the calculators, don't put the pi's in the calculator. Just work with the numbers. And then just reattach the pi to your answer. For converting from radians to degrees, so I'm starting with 3 pi over 4. And that's in radians. And what I need to do is I need to be able to cancel out the radians, which means the pi is on the bottom, since pi represents radians. And then on the top I have 180 degrees. So my radian units are going to cancel. My pi is also going to cancel. So then that leaves me with 3 times 180, multiplying straight across, is 540 degrees over 4, which is 135 degrees. So again, you're either multiplying by pi over 180 or 180 over pi. So if I'm starting with degrees, like I did for letter A, I'm multiplying by pi over 180. If I start with radians, like I did for letter B, I'm going to multiply by 180 over pi. The next thing we're looking at is converting from decimal degrees to a unit called degrees, minutes, and seconds. So that's what the DMS stands for. Degrees, minutes, and seconds is just another way to break down the decimal of a degree. And degrees, minutes, and seconds is used a lot in like nautical stuff and geographic coordinates, which is kind of why we do it. But you can break down a degree into minutes and seconds. So 1 degree is equivalent to 60 minutes, and 1 minute is equivalent to 60 seconds, just like in regular time. And this right here is just a little note that 90 degrees is equivalent to 89 degrees, 59 minutes, and 60 seconds. Okay, so the first thing we're going to do is convert the angle to a decimal degree form. So I'm starting with 73 degrees and 34 minutes. So that 34 minutes right here needs to be converted to a decimal. So 34 minutes, I can take that and divide it by 60 minutes. And then that gives me, let's see, 34 divided by 60. That gives me 0.567 because I'm rounding it. So that means when I convert 73 degrees and 34 minutes into a decimal, that's the same thing as 73.567 degrees. And then when I'm trying to convert the angle that's in a decimal into degrees, minutes, and seconds, what I can do is I can take that decimal, so 0.8, and I can multiply it by 60 minutes, and that'll tell me how many minutes I need. So 0.8 times 60 is 48 minutes. So that means negative 145.8 is negative 145 degrees and 48 minutes. So when you start with the degrees and the minutes, you're dividing by 60. You're taking the minutes and dividing it by 60. When you start with the decimal, you're going to take the decimal and multiply it by 60 to get the minutes. Now your calculator can actually convert back and forth from decimal angles to degrees, minutes, and seconds. So let's go ahead and start with letter A again. So I'm going to start by typing in the 73 into the calculator. If you'll notice, right above apps, you see that word angle. So you're going to hit second and then apps. And it gives you the degree symbol. So it was 73 degrees. Again, I'm working with letter A. 73 degrees, so I'm going to select the degree symbol. And 34 minutes, so I'm going to type in the 34. And then I'm going to hit second angle again. And you have that symbol for the minutes. And then if you hit enter, it'll automatically change that to the degree decimal. And then if I'm starting with the degrees, minutes, or when I'm starting with a decimal and I want to change it to degrees and minutes, I'm going to type in negative 145.8 like we have for letter B. You don't necessarily need the degree symbol there for the conversion to degrees, minutes, and seconds. But from there, you're going to hit second apps again. And then if you look, you see option number 4 where it says DMS. So when I select that and then hit enter, it'll tell you it's negative 445 degrees and 48 minutes, and this one had 0 seconds. So you can always convert back and forth with degrees, minutes, and seconds under calculator if you wanted to. Okay, the last two things we're looking at is arc length and area of a sector of a circle. So the formula for arc length of a circle is S equals R theta. I'm going to go ahead and draw a picture of what this actually means. So here's a circle. There's a lovely circle. Let's see, I have my angle measure. So this right here is theta. And the radius is this length over here. And what we're looking at is this arc, which I'm highlighting in purple. This right here is your arc length. And that's what S is. So I have S equals R theta, so S is the arc length, R is the radius, theta is the angle measurement, and it has to be in radians. Super duper important. So if I give you an angle measurement that is not in radians, let's say it's in degrees, you will have to convert it to radians first. So letter A, in a circle of radius 100 inches, an arc of 130 inches subtends an angle of how many radians as a fraction and how many degrees to the nearest degree. Okay, so here's what's happening. I have a circle. My radius is 100 inches. The arc length is 130 inches. And what we are trying to find is theta. So let's plug in what we know. My arc length is 30, or 130. My radius is 100. And what I'm solving for is theta. So from here, I can divide both sides by 100. So 130 divided by 100 is 1.3. So my angle measurement is 1.3. It does ask for it as a fraction, so let's math frac that. So that is 13 tenths of a radian. So here is your angle measurement in radians. It also asks how many degrees to the nearest tenth, or to the nearest degree. So now I'm going to convert this radian measure into degree measure, which I'm going to do in blue. So I have 13 tenths radians, and I'm going to multiply that by 180 degrees over pi radians, so I can figure out the actual degree measure. So my radian units cancel. I do still have the pi, because I didn't actually have a pi to cancel it with. So I'm going to take 13 times 180, which is 2,340, divided by 10 pi. Pi on the calculator is right underneath the clear button. So if you hit second, and that's the little exponent key, you can put the pi in the calculator. So 2,340 divided by 10 pi is approximately 74 degrees. So it's either 13 tenths of a radian or 74 degrees. For letter B, how long is an arc intercepted by an angle of pi over 3 radians in a circle with a radius of 8 inches? So I'm trying to find my arc length, but I do know the radius is 8, and I also know the angle is pi over 3. Now your angle measurement does have to be in radians, and pi over 3 is in radians, so we're good to go. So I'm going to take that expression and plug it into my calculator. So 8 times pi divided by 3. And this says round to the nearest hundredth. So that's 8.38. And my radius was in inches, so that means my arc length is also in inches. Alright, so that is arc length. Last thing is area of a sector of a circle. So instead of finding the arc length, you're actually finding the area of that particular portion. So your area is 1/2 r squared theta. And again, your angle measurement has to be in radians. Super, super important. So a sprinkler on a golf course fairway sprays water over a distance of 70 feet and rotates through an angle of 120 degrees. Find the area of the fairway watered by the sprinkler. So you have this drawing over here. So this radius is 70 feet. My angle is 120 degrees. And what we're trying to find is this part that actually gets sprayed with water from the sprinkler. Now I do keep saying that your angle has to be in radians. So the first thing I need to do is I need to take 120 degrees and convert it to radians. So now I'm going to multiply this by pi over 180. So my degrees cancel. That leaves me with 120 pi over 180. And 120 divided by 180 can be reduced to 2/3. So that's 2 pi over 3. Okay, so now that I have my angle measurement in radians, I can go ahead and find the area. So my area is 1/2 times r theta. My radius is r squared, not r theta. My radius is 70. So 70 squared times theta. And I can take this entire expression and plug it into the calculator. So 1/2, so 0.5, times 70 squared times 2 pi over 3. Again, pi is right above the little exponent key. And that gives me 5,131, what are the units? Feet squared. So that's the area that the sprinkler actually covers. Alright, so that finishes up your lesson for section 4.1.